and we know they come together to form an ionic compound. Potassium is a +1, carbon is a -4. What would my equation be? Okay, so we'd need 4 potassiums and 1 carbon. Okay, so there's our balanced formula equation, or molecular equation. Now when we write the complete ionic equation, that's what really shows us what's going on with the charges, how the left side and the right side are different. On the left side here, it stays the same. We don't have any ions. On the right side though, this is an ionic compound. So what's my cation in this compound? Good. And how many potassiums do I have? 4. Remember when we're separating them to show that they're separate, we put it out in front instead of down below. So we have 4K plus C -4. So what's going on there? Let's take a look at potassium. Potassium's charge is going from, if nothing's written there, it's a 0. So it's like having a 0 there. If nothing's written there for carbon, its charge is a... Okay, so potassium's charge is going from a 0 to a +1. Carbon's charge is going from a 0 to a... Which one of those is going down in value? Carbon's going from a 0 to a -4. So the particle that's reduced is carbon. Carbon's reduced. That means the particle that's oxidized, or numbers going up, its charge is going up, is this is reduced because the value goes from 0 to -4. This one is oxidized because it's going from 0 to +1. Follow that? Okay. So from there, we can write our equations. So our oxidation half reaction would be just the particle that's oxidizing, what's going on with it. So on the left I would have 4K. Okay. What did it have to give up each one of those in order to become +1? What's the difference in the electrons here? 0 and +1. How many did it get rid of, each one? Good. And there was 4 of them, so all in all, they got rid of how many total? Good. So we have 4E-. So this is showing what's going on with potassium. It started off as 4 neutral atoms. It ended up as 4 positive atoms. In order to do that, it has to get rid of 4 electrons. So this is saying that potassium is sending 4 electrons to carbon. Carbon's being reduced in value, so reduction half reaction is just carbon. Carbon, how many electrons did it need to become -4? Yeah, the E is always a negative charge because it just stands for an electron.
How do you have to add
For the reduction half reaction? Because what we're saying is this carbon here had to receive these 4 electrons in order to become carbon with a -4 charge. So this is like the steps of what's going on in the reaction. First, the potassium is getting rid of the electrons. That has to happen before carbon can accept them, right? So here potassium is saying, I got rid of 4 electrons, now I have This is 4 positive potassium ions, right? Now, carbon's taking on 4 electrons, and if it does that, it becomes a -4 charge. Okay. So now when we say the oxidizing agent, true, add electrons, because otherwise it couldn't be reduced in charge, right? It's a good way of looking at it. So every time there's a reduction, 4 electrons added on the left become a -4. Every time there's oxidation, that means that has to get rid of these electrons for charge. So this is like the first step. Potassium gets rid of its 4 electrons, so carbon takes on those 4 electrons, and these on the right are what we end up with in our final equation. K plus is C -4. Okay? Oxidizing agent. Agents, we mean what allows the oxidation to occur. So what allows potassium to be oxidized? What takes these 4 electrons? Good. So carbon's the oxidizing agent. Reducing agent. What allows carbon to be reduced? What provides it with these 4 electrons that it needs to be reduced? Potassium. So the reducing agent is the what? Electron donor or acceptor? Which one's getting rid of electrons? Good. This is the donor of electrons. And the electron acceptor is good. Does that make sense? Okay, so do you want to do one that's, let's do one that's a single replacement reaction now. So let's start with a single replacement reaction. And we're going to do one from our virtual lab.